Alright guys, we are going to go through the 2.5 power rule practice Deltamath assignment, and I do have a little bit of like virtual scratch paper over here, so my recommendation is you guys would grab something as well. And I'm just going to go through and do a couple examples of each of the types of problems. Okay, so power rule, single term, let's do it. So for the following equation, find dy dx, which just means find the derivative of y with respect to x, so I'm finding the derivative of this function. So the derivative of x to the fourth, bring down that exponent, subtract 1 from its exponent, so I have 4x cubed. Boom, look at that. They get real fancy with it, but you don't need to. All right, this one. Let's see, 5e to the 4th, well geez, 5e to the 4th, well that's just a number, right? E to the 4th is just Euler's number to the 4th times 5, so that's just a constant. And what's the derivative of any constant? Well, that would be 0. Right? Since e is a constant, then 5e to the 4th is also a constant. Because remember, for any function that's a constant, right, that means that on an actual graph, regardless of what it is, so in the scenario 272.99, right, the slope at any point on that constant graph is 0. That's how we know the derivative of any constant is 0. All right, 7x to the 5th, so my 7 hangs out. Bring down my 5x, subtract 1 from my exponent, and I have 4. So dy dx would equal 35x to the 4th. And again, you're going to get really good at just like bringing down the 5, multiplying it, get 35x to the 4th. Okay, let's go do some polynomials. So these ones you have to do each of the pieces, right? So if I do it, -6 and then 4x cubed minus 5, 3x squared. Derivative of 4 is, that's a constant, so it's 0. So I'll end up with -24x to the 3rd minus 15x squared. You, to be getting these exponents, hit Shift 6 on your keyboard, or you can also use this keyboard and you can click either squared, or this one will allow you to type in any exponent. All right, let's see if we can do this one without writing anything down. So 8x to the 4th would be, bring down that 4, multiply it, so 32x cubed minus 3 times 3 would be 9x squared. Derivative of x squared would just be plus 2x, right? Bring down that 2, subtract 1 from the exponent. Derivative of -4x is just -4, because I bring down that exponent, which is 1, multiplied by -4, which is just -4, and then subtract 1 from my exponent, so I get x to the 0 power, which is just the number 1. Cool. So those are how those problems kind of go. All right, let's do a derivative with function evaluation. So in this one, they not only want you to find the derivative, so they want you to find f prime, find the derivative at a particular x value. So let's find f prime of x first. If I do that, -4x cubed, right? Bring down the 4, multiply it by the negative, and subtract 1 from your exponent. And the derivative of -3x is just a -3, because bring down my 1. Subtract 1 from my exponent, it'd be 0, x to the 0, which is just the number 1. And now they want me to actually evaluate f prime of -1. So then I'm going to go ahead and plug in a -1. -4, -1 cubed is still -1 minus 3. So 4 minus 3, which is just the number 1. Cool. And they did exactly the same steps as what I did. All right, let's try one more of these. Find my derivative. Well, and I know it wants me to find my derivative because it says for the following equation, what is the instantaneous rate of change? Remember, our derivative is our instantaneous rate of change. It's also the slope of our tangent line, and it's also known as the derivative. F prime of x would be -4x cubed minus 8x, and then I'm finding f prime of x at -2. So then I'm plugging it in. -4 times -8. -2 cubed is -8. Oops. And this would be a +16. 32 plus 16, give me a whopping 48. Cool. All right, let's go on to some power rule. Ooh, a little more complicated levels, huh? Okay, let's do this. So a couple of things to remember, first and foremost. So if I have an x with radical stuff going on, here's your power, and here's the index, the type of root you're taking. We can rewrite that always as x to the power over index. We can write it as a fractional exponent. And then if you have like 1 over x, like to the fourth, that's secretly x to the negative 4. Okay, because we always want to be able to write things as powers of x in order to take the derivative of them. So in this one it says, given the function f of x equals that stuff, find f prime of x. So we're going to rewrite this. First and foremost, I notice that I can rewrite this x to the third under the fifth root. I could rewrite that as 4 over 3x to the, 3/5. Okay. But in order to take the derivative of it, I need to like bring it up and have it not be in the denominator. So then this is really the same as 4/3 x to the negative 3/5. Now this is in a form that I can actually take the derivative of. So taking the derivative of this, write out a little bit of extra work. So my 4/3 is still there, right? Then I'm bringing down my negative 3/5 x, and I'm subtracting 1 from my exponent. If I do, off to the side, you guys should be pretty good at this. We did hit this a lot in pre-calc. Negative 3/5, and I'm subtracting 1 from it. You need common denominators. So negative 3/5 minus 5/5 would give me negative 8/5 as my new exponent. So negative 8/5. And then we're going to simplify that. So multiplying fractions go straight across. So 4 times negative 3 will give me negative 12 over 15. And then we'll have to reduce that probably. X to the negative 8/5. And it wants my answer in radical form without using negative exponents. Okay, we can do this. So negative 12/15 would reduce to, what's that, negative 4/5. Yep. And I'm going to move this guy back down to the bottom. All right. And then let's see, last thing we have to do is we have to change this back to a radical because it wants it in radical form without negative exponents. So we get negative 4 over 5, power over index, so x to the 8th. Oh, goodness. 5th root of that. All right, I'm going to try it. I'm guessing Deltamath is going to be extra picky and make me do one more thing, but we're going to try it just for a second to see if it will let me do it. Oh, yes, it was good to go. Beautiful. Negative 4 over 5, 5th root of x to the 8th. And they work through it exactly the same way that I worked through it, right? Cool. I don't really like to, like the way they wrote their 4/3 like that. I like to actually write it as fractions. It's easier for me to work with, but you guys do you. Whew. All right, this next one hopefully isn't quite as long. So for this part, I have the square root of x over 3, so I can really rewrite that as f of x would equal 1/3 x to the 1/2 power, right? Because the power is 1 and a square root secretly has an index of 2. So then when I take the derivative of that, f prime of x, my 1/3 hangs out. I bring down my 1/2, subtract 1 from that. 1/2 minus 1 is a negative 1/2. So then I'd really get 1 over 6, and then I'm not allowed to have negative exponents. So I'm going to bring that down here. And then rewriting the x to the 1/2 as a radical is 1 over 6 x to the first, and that's square root, right? Index is 2. So 1 over 6 square root of x. Nice. All right. Level 3, let's do it. Oof, okay, sounds good. And given the function blah, 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 find f prime of 6, express your answer in a single fraction in simplest radical form. All right, so let's rewrite our function first so it has some nice exponents with it. So f of x will equal 2/3, and then that would be rewritten as x to the 3/2, right? Power over the index, and the index would be 2 for a square root, plus 1/2 x to the square root of x is 1/2 like that. Power is 1, index is 2. So then let's take the derivative of each piece. So 2/3, bring down that 3/2 and subtract 1. 3/2 minus 1, get some common denominators. I should be doing this in a different color. So 3/2 minus 2/2 gives me 1/2. Plus 1/2, bring down the 1/2, subtract 1, I get negative 1/2. Okay, so then this is f prime of x. I'm finding the derivative here. All right, 3's would cancel, 2's would cancel, so I just would be left with x to the 1/2 plus 1/4 x to the negative 1/2. Not allowed to have negative exponents, so I'm going to go ahead and bring that down to the denominator. So then I'll have x to the 1/2 plus 1/4 x to the 1/2, and now we can rewrite them as radicals. So power over index would be square root of x plus 1/4 square root of x. And then I'm trying to find f prime of 6, so then I'm actually going to plug in f prime of 6 into this answer, which is not going to change very much. I don't think I can, you can't actually take in the square root of 6, so this will be in simplest radical form. Oh, as a single fraction. Oh, that's so mean. Hold on. I just read what it wanted me to do. Gotta get common denominators and actually combine these things. So from here, this guy would be, oh shoot, this guy would be missing 4 square root of x on the top and bottom. Secretly over 1 right now, right? All right, so then we get 4 square root of x times square root of x is x plus 1. Now it has the same common denominator. There we go. All right, so then now we can plug in 6. Goodness, that was extra. Extra. There, I just wanted to show that that's our derivative. Okay, so now when I find f prime of 6, 4 times 6 plus 1/4 times square root of 6. So we will get, let's see, 25/4 square root of 6. I'm going to be real mad if this is not the answer. Ooh, heck yeah. Oh, they waited and got common denominators afterwards. I would do it here because then I don't want to get mixed up with my square roots of 6's and doing lots of stuff. So as long as you get the final answer. All right, obviously the level 3 ones are the hardest ones, but if you're like having legit trouble with it and you want to work through problems with me, I only need you to get 3 right. Come to my office hours or just set up a time to meet with me separately, and we can just literally, you can pull up your screen, show it to me, and I'll be like, I will help you through it. I promise. Cool. All right, thanks guys.